So now we're going to go through our last three types of reactions. Our first one is single displacement. And in single displacement, one element and one compound react, which produces a different element and a different compound. Obviously, all the same elements are involved, but we're going to start reacting one element and one compound. It's easy to see when you look at it. Element plus a compound yields an element plus a compound. We haven't forgotten about these Hunkelbriefs here. We haven't forgotten about the fact that they like to be diatomic when they are by themselves. So now we have to go ahead and look at our balancing. So let's put our blanks in. Now, when we balance things with polyatomics, we can either count them up individually, like one phosphorus over here and two phosphorus over here. But if I recognize that I have, and I will highlight it here, if I recognize that I have phosphate here and phosphate here, I can treat that whole group as sort of one thing to balance. So I can say that I have one phosphate and that I have two phosphates. And so I'm going to start right ahead with that. So one phosphate and two phosphates, I'm going to go ahead and put a 2 here. Then I'm going to look here and I'm going to say, well, that changed my 2 times 3. Now I have 6 hydrogens, so I need to put a 3 here. And then I have 3 irons, so I need to put a 3 here. And that makes my equation balanced. Okay, so looking at, even though it's a more complicated reaction, my balancing is still pretty straightforward and pretty simple. I don't have any large numbers. Here's another example. This is an element plus a compound, which is giving us a different element and a different compound. So let's look here. I have 2 hydrogens. I have 2 hydrogens. I have 1 copper. I have 1 copper. And I have 1 oxygen, and I have 1 oxygen. So this one is already balanced. Nothing I need to do there. Again, element and compound gives element plus compound. I have 1 zinc and 1 zinc. I have 1 hydrogen and I have 2 hydrogens, so I'll go ahead and put a 2 there. Now I have 2 hydrogens and 2 hydrogens, 2 Cls and 2 Cls. So now I'm good. And my last one here, element and compound gives element and compound. 2 Cls, let's go ahead and put a 2 here. That gives me 2 Ks, let's put a 2 here. 2 Ks, 2 Brs, and I have 2 Brs, so I am balanced. So that's single displacement. The next one that we have, type number 4, is double displacement. And double displacement is 2 compounds producing 2 different compounds. I'm going to do something a little bit different here. I'm going to go ahead and put up all 4 of our reactions, sample ones, and I want you to copy them down, and I want you to pause the video and try to balance them. Okay, as they get more complicated, I want to make sure that you're able to do them. So please go ahead and copy them, and then pause the video, and then I'll walk through the solutions. Okay, good. Did you try them all? Let's take a look. I'm just going to take a second and pull up my highlighter again, because again I see this nitrate here, and I see nitrate, and I see sulfate, and I see sulfate, and I see nitrate, and I see nitrate, and I see iodate, and I see iodate, and then one more color here, because in my first one I see hydroxide and I see hydroxide. So I wanted to highlight all of those polyatomics. So now let's take a look at them. What I need to realize is that if I'm, I need a pen back. If I am looking at nitrate and that contains oxygen, and I'm looking at hydroxide and that contains oxygen, I realize that all of my oxygens are occupied in these polyatomics. So what I'm doing with balancing, by balancing the polyatomics, is totally okay. If there was oxygen somewhere else, I might have to separate the elements up. But for the most part, as long as I see the polyatomics on both sides, I'm good. So here, I have 1 aluminum, I have 1 aluminum. I have 3 nitrates, but I only have 1 nitrate. So let's put this here. I have 3 sodiums. Now I have 3 sodiums. I have 3 hydroxides, and I have 3 hydroxides. Sometimes when it's complicated like this, it's good to go back. 1 aluminum, 3 nitrates, 3 nitrates, 3 sodiums, 3 sodiums, 3 hydroxides, 3 hydroxides. Let's check this one. I have 1 lead and I have 1 lead. I have 2 Cls. So let's put a 2 here. I have 2 Lis, so I have 2 Lis and 1 sulfate and 1 sulfate, all balanced. Let's check this one out here. I have 1 zinc, I have 1 zinc, I have 2 Brs, I have 2 Brs, I have now 2 Ags, so I have 2 Ags, I have 2 nitrates, and I have 2 nitrates, so done. And let's check out this last one here. 1 Ba, I have 1 Ba, I have 2 Cls, now I have 2 Cls, I have 2 Ks, now I have 2 Ks, I have 2 IO3s, I have 2 IO3s, all balanced. Our very last type is combustion, and this is the hardest one for people to recognize, and it's not hard at all. It's a hydrocarbon, which is any compound that contains hydrogen and carbon. Occasionally it will contain hydrogen, carbon, and oxygen. Reacts with oxygen to produce carbon dioxide and water. And so if we look at one of these, a lot of times people don't look closely enough at the products. They say compound plus element and they think it's a single displacement. That is the most common mistake. But CO2 and H2O are always your products. Take a look at this other example. Again, hydrocarbon, but look, CO2 and H2O, 100%. So don't make the mistake that a lot of students make by calling this a single displacement. Make sure you look at the whole reaction. And don't just rush ahead, because you want to make sure that you recognize that this is a combustion reaction. These are the ones that are the trickiest to balance, not that they're crazy hard, and they can have sometimes slightly higher numbers than we've seen with our 2s and 3s and 4s so far. And the reason they're tricky is because oxygen is in both products. And a lot of times we have to go back in and double everything. So if we look at this, my strategy is I always leave my oxygen by itself for the last thing to balance. So I'm going to start with my carbons, 1 and 1. And then I'm going to move on to my hydrogens, 4. And then I have 2 here, so I'll put a 2 here. That gives me oxygens. I have to remember to add up 2 times 1. So I have 2 oxygens here. And I have just 2 here. So I have 2 plus 2. I have 4 oxygens. And I have 2 here. So I'll do that. And I'm balanced. They're not always as straightforward as that. Let's take a look at this one here. Again, I'm going to leave my oxygen for the very last. I have 6 carbons, so I'm going to go ahead and put a 6 here. I have 12 hydrogens, so I'm going to put a 6 here because it's 6 times 2 gives me 12. And then let's see how many oxygens I have. I have 6 times 2, so I have 12. And I have 6 times 1, so I have 6. So I have a total of 18 oxygens over on this side. I can't just go ahead and throw a 9 in here because I can't forget about these oxygens. So I need to subtract them out. So I need to have 18, but I'm going to subtract these 6. So I really need a total of 12 more, which means I'm going to put a 6 here. And I can always go back and check 6 and 6 for my carbons. 12 for my hydrogens, 6 times 2 is 12. 6 times 2 is 12 plus 6 gives me 18 oxygens. 6 times 2 is 12 plus 6 gives me 18 oxygens. Notice my numbers are a little bit higher. And these are our 5 types of reactions. So we will practice again with these, and then we'll be moving on to writing formulas from names. I hope that we are practicing that formula writing and polyatomics.